Hello YouTubers, welcome to another video. In front of you are two, I may say, old component tester, not vintage. These are from the 90s or late 90s. They were made by Peak Electronics of United Kingdom and was sold by Farnell. Farnell now are known as by Element 14. I think by now Peak Electronics are known to many in the component testing tool, and these two have evolved into something which is uh, has more features and has the ability of measuring a lot more component than before. Yeah, on the left is the DTA30, which is a transistor analyzer. On the right is a MOSFET analyzer model HMA20. So back then, in 1999, I was in charge of repairs in a music shop. I worked for a music shop, and they didn't have any equipment available to aid my repair work. All I had was a cheap DMM and a soldering iron and a few screwdriver to start or to begin my journey then. So I had to look for a tester that would help somebody like me, because I didn't know how to measure diodes, or not to say diode. I didn't know how to measure transistor using a DMM. So I had to search for something that is quick and suitable for a silly person like me. So these were the two choices that were available back then. I didn't know any other tester that exists, so came across this and I bought it. Yeah, it turned out to be very helpful in determining whether the component or the transistor is good or bad very quick. Yeah, and I'm gonna do some demonstration. I think I've shown this years ago for a short while I was reviewing a Chinese component tester. So yeah, on the left I prepared two transistors, which is TIP35 and 36. So the way to use this is quite self-explanatory actually. These three crocs just clip to each leg of the device under test, and press test. Let me get the focus and then the contrast correct to the so we can see the difference in the LED color. So yeah, something to point. So this shows this transistor is a PNP type. This is the type indicator, and shows you obviously it's a good transistor, while indicating the LED color according to the crocodile clip that attached to the leg of the component and the device. For example, in this one is the base is the green, which is this green wire going to the most right of the leg, and the emitter is the red LED, which corresponds to the red crocodile going to the far left of the component, and the non-littered LED is the black, so that shows is the collector. So this shows this transistor is good. I don't have any bad component or transistor to test, but I can simulate the what happen if a transistor has an open internal. So I'm gonna take out one leg. So if I were to come across with a bad component, it will flash all red several times. I didn't count it. Yeah. Next, we're going to proceed to the other transistor. My apology for not preparing a lot of transistor. I think it is suffice to show the testing procedure with the given type. So this is a TIP35C. Press test. So it's showing it's a NPN, which is a complementary of the previous one, and it does not matter where you put this crock on the leg of the device, because it can figure out what goes where and will tell you what is what according to the color of the crock wire and the LED that's lit. So in this case we have the base is the green, non-color is the emitter, which is the black one far left, and the collector is the red, which now is in the center. So that crock is in the center leg. Yeah. In case of a short, let me short the base to the collector and simulate a short of a device. Same thing, it will flash all red, showing or indicating that is you have a bad component. It's quite convenient actually, this kind of tester. You don't have to deal with a lot of information like the China tester or nowadays the newer PIC. You have too much information, which personally to me, if I see more information, I need to worry more about that information and verifying whether those given numbers or data on the display is correct or those kind of things. So I like this kind of thing. I occasionally use this every now and then just for the fun of it, and just to bring back some old memories. And we're gonna go to the MOSFET analyzer, the HMA20, and I have a MOSFET here. This is a, what is this? Can't see. It's a K1058. So I'm going to randomly put the crock randomly on the legs of the device and the test, and press test. So this is showing you is an N channel MOSFET with the indicated gate drain source according to the same style as the transistor analyzer. The red is the gate, the source is the green crock or green wire, green LED at the center of the device and the test, and the non-lighted LED is the black. So yeah, and I'm gonna measure the complementary of this, which I happen to have also. So this is a J162, and I'm gonna randomly crock each leg. Again, same thing, if you have an open device or broken, it will flash. Yeah. So this is now is a P channel, and black shows you the gate, green shows you the center is the source, and the red is the drain. So quite simple and easy to use. Now I'm gonna dismantle this and open. It doesn't have any screw, so to access the battery, you need to use something that is like a screwdriver to pinch open this, but mine is already worn out, so I can just squeeze and open it. Nothing broken actually, it's just worn out a bit. So yeah, the plastic hook is still intact. So that is the battery itself, and let me focus, get the contrast correct. So that is the model DTA30 by PIC. I think this was made on 30th of October 1997. That's my theory. And it shows you the equivalent the battery type and the equivalent battery code in case you can't find a specific model. There are a variety of substitute or replacement that is suitable. Uses an odd size battery, so it's a 6 volt. I can't buy this battery from a normal hardware shop or supermarket. It had to be ordered, and I just replaced these two recently because I started using it for the fun of it. Yeah, and underneath the board, I'm gonna disassemble one. I have seen both of these unit internally. They look identical. They use the same IC. The only thing difference is the perhaps the programming or the code that is embedded in the IC itself for it to function as it's intended. So this is the IC. It's a one IC job actually. It's a PIC, it's a programmable IC. I'm not familiar with the IC, but however, what I do know about this IC is it's quite popular back then, and it's like you're buying a blank IC. You buy it and then you program it, and it becomes something that you want it to be. So it's good at putting special program and while not divulging your technical coding, as opposed of buying a preamp, op amp. People know you're using this op amp or that op amp. People can copy. This needs a higher degree of knowledge to program, and at least gives time before someone clever figures out what you're doing with the IC. Yeah, so I think by now a lot of variant of this has come out, especially from China. So yeah, that is the my apology if I didn't focus it just now very steadily. So nothing much for me to explain because I don't know what to explain. Yeah, so it is identical to both unit. They should have combined these two become one. So yeah, instead of me having to buy both, but it's how it is. Other way around, sorry. So it's quite a smart way to make money. So yeah. Yeah, let's look at the MOSFET analyzer and see some information inside of it. So yeah, same thing. The only difference, if I happens to misattach the front cover, the only telling indication of what goes where is the color of the button itself. So red is the transistor analyzer, blue is the MOSFET analyzer. In case I put this here, so I know it's wrong. So yeah, and yeah, this is the model number, which is the HMA20, made slightly later than the other one. Is made on the 20th of November 1997. So I think over 20 years ago, I believe. 97, 2007, 2017. So now it's 2019 and nearing 2020. Yeah, 22 years, close to 23 years. Yeah, I think that's it for today. I think I've explained much about this obscure test tool, which I may say it's a very simple to use device, and especially for, as I said, for somebody like me, which requires simple indication without too much of technical info on the screen. Those who find those things helpful would appreciate those kind of modern stuff like what's found today. So yeah, that's it for today. I hope you enjoy this video, and if you have any question, you can write down there. I will try to answer as much as I know, but I think everything has been covered in this video. And yeah, that's it for today, and thank you very much, and bye bye.